equations in y equals mx form. So just harkening back here, don't forget what, let's say x is our input, y is what we get out of it, our output, and m is the slope, or that rate of change that we see in the relationship between the input and the output. Okay, so we're talking about equations in y equals mx form, and when we put a digit in for this, we're going to have a digit in for m. Now let's just take this table here. Let's say you're a runner, and you're running for a cause, and you get people to pledge money, and for every mile you run 2 miles, you've raised $20, 4 miles, $40, 6 miles, $60. If we go back to our proportionality here, so I have 20 over 2, 40 over 4, 60 over 6. We can simplify all those to 10 over 1, 10 over 1, 10 over 1. And all we did was take our y's as our numerators and then our x's are denominators. So we have a constant of proportionality here. This is a linear number set. It is proportional, and because it's proportional, if we were to write an equation for it, it would be in this format. And what we call this format is a shortcut here, is we call it direct variation. Now, direct variation means that our x is only having one thing happening to it. There's a direct variation between the input and the output, so that whatever's happening for the input is giving us the exact same proportional output every single time. Now, the twist with this is that when we have equations that are y equals mx, and let's go back to this equation here, our constant of proportionality here is 10. So we could write this equation as y equals 10x. Now, just to connect these two together, whatever x is, if I put 2 in for x, I get an output that's 20. If I put 4 in for x, I get an output that's 40. So on and so forth. We can figure out 1,000 miles or 800 miles or 32 miles with this equation. Now the twist of this is that this is the slope, right? That's m. But m, in a direct variation equation, m is also the constant of proportionality. And that's just nality. There we go. That's just saying that each ratio of y over x is exactly the same, and it says m. It is also the slope of the equation. So if we were to draw this line, it is the slope. So it is this for this one, and this it's rising 10 and going to the right one, rising 10 going to the right one. It is also the unit rate. All three of those things in a direct variation equation are m. Now, direct variation equations we can represent a few different ways. Let's do this here. We've got our table here, so let me erase this. We've got our equation here. Let me rewrite that. Okay. So we've got y equals 10x. So we can write direct variations in a few different ways. So we have it as a table. We could write it as a graph. So let me just do it in a formal graph here. And we'll go 1, 2, 3, 1, 2, 3. And let's go 10, 20, 30, 40. I'm breaking all the rules of symmetry here. 40. So I've got 110, 220, 330. And that line goes like that. Okay. We can also write it as an equation. So we have it as a graph, a table. Let's get a different color here. An equation, or we can write it in words. And for words here, we'll say the runner ran, no, not ran, earned $10 per mile. And then the key phrase here in these problems is you're going to look for y varies directly from x. So that phrase is our words indicator that we have direct variation going on here, that we have a y equals mx equation. Because of that, then we've got the ability to say that whatever the m is, it is the slope, it's the unit rate, it's the constant of proportionality, is that we know that if our statement says y varies directly from x. Here we have a graph. And what we're going to try to do with this graph is, let's figure out what the equation is for this situation. So what we have is, we have somebody, let's say it's Ella, and Ella's a babysitter, and this is how much she works. These are the hours that she works. This is the amount of money she makes. So let's pick out some points and see what the constant of proportionality is here, so that it tells us what the slope is. Let's look for some spots where our lines kind of cross nicely. Here's one right here. I've got another one there. Let's use those two for now. So here I've got, in 2 hours, there's $15. And we also have 4 hours is $30. So looking at those two, let's check to see if they're the same proportion. So if we cut 15 in half, we have $7.50 per hour. If we cut 30 in half twice, which is dividing it by 4, we would also have $7.50 per hour. And what that means is that our constant proportionality here is $7.50 for every hour. Our unit rate is this, but more importantly, that is the slope. And since we know that's the slope, we can go back and we can use this and say y does equal 7.5 times x. So any number of hours we could plug in and find out how much money Ella's going to make. I want you to notice something too. When we're doing direct variation equations, if we have something like this, y equals mx, if this is our example, if x is 0, what's y going to be? If x is 0, what's y going to be? It has to be 0, because 0 times anything is 0, which means in every direct variation equation, the line goes through 0, 0. Or as you know it, the origin. Here's an example that's in words. So let's see if we can tease out a direct variation equation from this situation. We got 2 minutes after a skydiver opens his parachute. He has descended 1,900 feet. So we've got 1,900 feet in 2 minutes. Okay? After 5 minutes, he's descended 4,750 feet. If the distance varies directly, there we go, varies directly with the time, at what rate is the skydiver moving? So I've got this one, or 4,750 over 5 minutes. Let's just reduce those and see if they're the same proportion. We're going to divide both of these by 2. So that's going to give me 1 minute is, let's see, 2 goes into 19 9 times with 1 remaining. 2 goes into 10, 5. 950 feet per minute. Let's check this one. This one we'll just set up as a quick, I'll show you some short division. This is short, something I learned when I was, when we were doing this on stone tablets. So 9 times 5 is 45. 47 minus 45 is 2. How many 5s in 25? 5. 5 times 7 is 25. That's 0. 0. Great. 950 feet for every 1 minute. So now what's the equation that we have here? The equation we would write, we have a constant of proportionality. We understand that it's proportional. We know that it's direct variation. Because it's direct variation, that y varies directly with x. So what we have here is that for every minute that diver is falling 950 feet, so 10 minutes would be 9,500 feet, 5 minutes would be half of that. Okay, now it's getting serious. So now we're going to compare direct variation equations. And when we compare them, now we're taking two different rates, two different unit rates, and seeing how they compare to each other. So let's look at the problem here. The distance y in miles covered by a rabbit in x hours can be represented by the equation that. Okay, so when I start these, let's keep track of what we've got here. We've got a rabbit, right? And that rabbit travels at this rate. So for every hour, it can go 35 miles. The distance covered by a grizzly bear is shown in the graph. Okay, so here's the grizzly bear. But we only have the graph. So let's take the graph, and because we have direct variation here, we know it goes to the origin. We can choose any point, because there's a constant of proportionality, to determine what our slope is. So let's just choose, I'll just choose 60 over 2. We could use 30 over 1. 30 over 1 we don't have to simplify. 60 over 2 becomes 30 over 1 when we divide both by 2. So we have a slope, a constant of proportionality, but let's just call it a slope. And now that we have a slope for this one, we can write this as the distance traveled is 30 x. Right? This is our time, this is our distance traveled. Now, the grizzly bear then is at that rate. The rabbit is at this rate. So we can see that the rabbit is faster. The rabbit's going to cover more distance than the grizzly bear per hour. Oh man, vocab for this one. Boy, this is important. V-O-C-A-B. What we need to know for sure is direct variation is y equals mx. What we should know about direct variation is it will go through the origin. We know that the slope, that m is the slope, it is the unit rate. Whoa, that's not a good slash. It is the constant of proportionality. Okay? We know that we can compare direct variation equations by checking to see what their slopes are. So if this was y equals 12x, y equals 11x, depending on what we were comparing, we could decide that this was faster and this was slower, or this person ate more hot dogs faster than this person did. That's how we can compare these. We can compare direct variations equations that way. Also, don't forget, like, some of that back understanding of this too is knowing that when we look at any equation in y equals mx form, that x is our input. How many minutes did you run? How many hours did you work? That y is your output. How many miles did you run? How much money did you make? And then the rate at which those things happen is the slope, or the unit rate, or the constant proportionality for an equation in y equals mx form, which is direct variation. Good luck.